Alright, in this video we're going to go over some AP Calc AB and BC multiple choice review problems. They're all based on problems that were on AB exams. So the AB exam contains things that could definitely be, like everything on AB could also be on BC. So that's why I'm calling it an AB and BC review. This is the fourth set of problems. There's a link to the problems in the description and a link to the playlist with all of the problem sets in it. So check that out. I recommend you get the problems, give them a try, and then come back, watch the video, and see if you agree with me. Alright, so let's get started on this. First question, a particle moves along the x-axis so that at time t greater than 0, its position is given by x of t equals cosine of 2t over e to the 2t. What is the first time t at which the velocity of the particle is 0? Okay, so we're looking for a velocity. So I'm going to start by just recopying this. For whatever reason, I find it easier if I have the original written right above where I find the derivative. Also, I'm going to rewrite it as e to the negative 2t times cosine of 2t, just to avoid using the quotient rule, basically. You get the same result either way, but I prefer to use the product rule if I can. So derivative is the velocity, and that's going to be first times derivative of second, which is negative 2 sine of 2t, because we've got some chain rule going on, plus second, which is cosine of 2t, times derivative of the first, which is negative 2e to the negative 2t. And I'm going to take negative 2e to the negative 2t out of everything. So negative 2e to the negative 2t. And then we're left with sine of 2t plus cosine of 2t. And our objective here is to find when the velocity of the particle is 0. So we're going to set it equal to 0. First thing I notice is that first factor, negative 2e to the negative 2t. We need that to be equal to 0 if we're going to get 0, but it's an exponential where it is not shifted up or down, so it actually never equals 0. So the only 0 could come from the second factor. So sine of 2t plus cosine of 2t equals 0. Alright, so this is like solving a trig equation. I'm going to move cosine over. So I get this. I'm going to divide both sides by cosine of 2t, which is kind of a dangerous thing to do, because now I'm assuming cosine of 2t is not 0. But you can kind of work out if cosine of 2t is 0, then sine is not 0, so adding them together would not be 0. So that couldn't have been a solution anyway, so dividing is safe. So I have this. Sine over cosine is tangent, so now I have tangent of 2t is equal to negative 1. This is a pretty annoying problem. And so I know that, so what do I know? Tan of 2t is equal to negative 1, and I want the first time that happens. So tangent starts out positive in the first quadrant, goes negative in the second. So from here is where I want like my original angle. And what angle in that quadrant has a tangent of negative 1? It's 3 pi over 4. So I know that 2t is 3 pi over 4, which means that t must be 3 pi over 8. So that is the first time that the velocity is equal to 0, and that's the answer that I would pick. So what do we get from this? There's a bunch of things, right? I avoided the quotient rule. I knew that an exponential was never going to be equal to 0 unless it was shifted up or down, so I knew there was no 0 from that factor. Did some trig equation stuff, and one key thing, know your unit circle. You got to know all the 17 famous angles, their sines, cosines, and at least be aware of their tangents. So let's move on to the next one. Let capital F be the function given by capital F equals the integral from 4 to x squared of secant squared of 3t minus 2t and then dt. We want to write an expression for f prime of x. Well, good. We're finding the derivative of an integral, so that's second fundamental theorem of calculus. So f prime is going to be, so it's the integrand here with the upper bound subbed in. So that's going to give me secant squared of 3 times x squared, because every t becomes x squared, minus 2 times x squared, and then times, by the chain rule, the derivative of the upper bound, so times 2x. And that's actually the entirety of this problem, so that's nice because it's a quick one. All right, Let f be the function given by f of x equals cosine squared of 2x minus 2 which almost feels like the last integrand, but I don't know, when you make enough of these problems, you kind of repeat some trends. Okay, so cosine squared of 2x minus 2. What is the approximation for f of 0.5 found by using the line tangent to the graph of f at x equals pi over 8? So this is a tangent line question, and then we're going to sub in. So for a tangent line, first let me just write down the function. So it's cosine squared of 2x and then minus 2. All right, so I need the slope and I need the value of the function. So let's get the slope. So f prime of x, going to be a chain rule thing here, the derivative of something squared, 2 times that thing, times the derivative of that thing is cosine, the derivative of cosine is negative sine of that thing, times the derivative of that thing is 2x, so the derivative is 2. So chain rule our way through there. All right, and we're just going to plug in pi over 8, so I'm not really going to simplify that. So this will give me 2. Cosine of 2 times pi over 8 is pi over 4, which again, you got to know your unit circle values, times negative sine of pi over 4, and then times 2. So that's going to give me 2 times 2 is 4, and then cosine of pi over 4 is root 2 over 2. Sine is also root 2 over 2, but negative because of the negative in front of it. So that gives me 4 divided by 4, and then negative 2. So negative 2. All right, that's the slope. I need the value of the function, so I got to plug in find f of pi over 8. So that's going to be cosine squared of pi over 4 minus 2. So cosine of pi over 4 is root 2 over 2. Square it, subtract 2. Root 2 over 2 squared is 2 over 4, which is 1/2. 1/2 minus 2 is 1/2 minus 4 over 2, so that's going to be negative 3/2. All right, let's write the tangent line. So just be methodical about these. Like, walk into the exam knowing you know how to use the chain rule, you know how to write a tangent line. Point slope form always wins. So we get this. And then if we're approximating and it's an open-ended question, don't forget your approximately equal to sign. So f of 1/2 is approximately negative 3/2 minus 2 times 1/2 minus pi over 8. So I don't know, this doesn't clean up all that well. So negative 3/2 minus 1 plus pi over 4. So that's, I don't know, negative 5/2 plus pi over 4. And then finally, I guess we could say that f of 1/2 is like, it's a multiple choice question on the exam, so like who knows what the answer choices look like. So I'm going to go with pi minus 10 all over 4. All right, next question. So next question is actually multiple choice. Let f be the function given by f of x equals 3 times the absolute value of x plus 4 over x plus 4. Which of the following is true? So which of the following is true? So this is a graph that you should know, the absolute value of x over x. I have a separate video about this. I think it's a really good graph to know because it has a jump discontinuity, which is probably going to be the key to this problem. So this one looks like this, and you can kind of work out why, right? Like, just pick any positive x, you'll get 1. Pick any negative x, you'll get negative 1. And then at 0, like, you don't get anything. So it has a jump discontinuity. So if I were going to graph the one that we were given here, 3 absolute value of x plus 4 over x plus 4, shifted 4 to the left, and then multiply the y values by 3. So negative 4, 3, negative 3, and then just kind of fill in. So being able to create this graph means that I can answer this question pretty easily. So we are looking for something that is true. So the first option here says the limit as x approaches negative 4 of f of x is equal to 3. But the limit from the left is negative 3. The limit from the right is positive 3. So the limit actually doesn't exist. That is false. So it is not the answer because we want something true. And then if you look at all the other answer choices, they're all about like what kind of discontinuity. But since we know what the graph looks like, we know there's jump discontinuity. So we can actually just pick that one. That is true. So C is our answer. So knowing the graph of absolute value of x over x, I think a really good idea. It's like an underrated graph. Not enough people know it. Make sure you do. All right, let's look at another one. If f of x equals natural log of 3x minus 2, then the limit as x approaches 4 of f of x minus f of 4 over x minus 4 is. All right, so this feels like a limit problem because there's a limit there. But as soon as you see like f of x minus f of a over x minus a, you should kind of think slope. if there's a limit involved, you should think derivative. This is actually the definition of the derivative. So it's the definition of the derivative, and it's asking you to find, basically, the derivative at x equals 4. So this is saying, find f prime of 4. And we were told what f of x is. It's natural log of 3x minus 2. So let's find f prime. So derivative of natural log is 1 over u times the derivative of u, so 3 over 3x minus 2. And therefore, f prime of 4, we just sub in, 3 over 12 minus 2, which is 3 over 10. So our answer is 3 over 10. All right, new problem. All right, we're finding the integral of 1 over x squared plus 6x plus 13 dx. So I look at this and I immediately think it kind of feels like I would try maybe u substitution where you use the denominator, but then you would need like a 2x plus 6 in the numerator, and we don't have that. So u substitution is not going to work for me. So now I'm thinking it's probably arctan. So if I'm thinking it's arctan, I'm going to have to complete the square. So I'm going to do that. So dx over, so x squared plus 6x, leave some space, and then plus 13. Take half of 6, half of the coefficient of x is 3. Square it, that's 9. Add that and subtract it. So plus 9 minus 9. Now when you do that, the first three things will be your perfect square, so that's going to be the quantity x plus 3 squared. And then the last part just cleans up, so this is just plus 4. And so I'm going to rewrite that. So I'm taking 1/4 out because I always want it to look like this. I always want it to look like dx over essentially 1 plus a thing squared. So x plus 3 squared over 4 can be rewritten as quantity x plus 3 over 2 and then squared. All right, so to make this perfect, I'm going to let u equal x plus 3 over 2. So then I need a 1/2 basically, right? So I'm going to put a 1/2 here. And that makes it perfect on the inside, but I need to balance that out. So I'm going to put a 2 on the outside. And then 2 times 1/4 is 1/2. It's perfectly arctan of whatever, and whatever is x plus 3 over 2. And then we put a plus c. All right, so completing the square is definitely something that you're going to be going to need to do. Also, you might need to do long division before you integrate. So completing the square when you have a quadratic in the denominator that's just like not working out with the numerator and u substitution, and long division when the numerator is a degree that is equal to or greater than the denominator. Those are two like algebraic techniques. They're relatively new on the exam. I think like 2018 maybe they showed up, but make sure you understand those and can do them. All right, new problem. Let f be the function defined by f of x equals the cube root of the quantity 3x minus 1 squared. What is the approximation for f of 3.2 found by using the line tangent to the graph of f at the point 3, 4? This is really similar to a previous problem that we did. Tangent line's a big deal on the exam because you have to just kind of know everything that they want you to know, right? Derivatives, approximations, tangent lines, point slope. All right, so let's just do the problem. Step 1, I think, is to rewrite this function using rational exponents. So it's going to be 3x minus 1 to the 2/3, right? So the exponent becomes the numerator of that fraction, and then the index of the radical becomes the denominator. And we can power rule our way through this. So f prime is going to be 2/3, 3x minus 1 to the negative 1/3 times 3. All right, by the chain rule. And I guess I'll clean that up. So, the 3 and the over 3, might as well clean it up. So we get this. Now we want to sub in, because of the point 3, 4, we want to sub in 3 for x. So f prime of 3 to 8 to the negative 1/3. So cube root of 8 is 2. So then to the negative first is 1/2. 2 times 1/2. So just 1. So our tangent line actually is pretty simple. So we get y minus 4 equals 1, quantity x minus 3. And then I'm approximating f of 3.2. So f of 3.2 is approximately 4. So open-ended, don't forget the approximate sign. Multiple choice, I don't know. All bets are off. Just do what you're going to do. So this is approximately 4.2. All right, not a bad problem. Let's take a look at number 8. We want the limit as x approaches 0 of e to the 3x minus 1 over 5x squared. So I'm going to do this one kind of like it's an open-ended question because I don't really do that work well enough in most of my videos. So first thing we're going to do is try to evaluate at 0. And you get e to the 0, which is 1, minus 0, minus 1. So you get 0 in the numerator over 0 in the denominator. So it's a L'Hopital situation. So what I'm going to do is I'm going to write that out, but I'm not going to make you watch me write that out. So I'm going to write limit as x approaches 0 of the numerator equals the limit as x approaches 0 of the denominator, which equals 0. Therefore, by L'Hopital's rule, the original limit is equal to, and now let's do it. So the limit as x approaches 0, derivative of the numerator is 3e to the 3x minus 3 over derivative of the denominator is 10x. Okay, so we try to substitute, we get 3e to the 0, so 3 minus 3 is 0 over 0. So we're going to do it again. So again, I would write this. Limit as x approaches 0 of the numerator equals limit as x approaches 0 of the denominator, and they both equal 0. Therefore, by L'Hopital's rule, this limit is equal to the limit as x approaches 0 of derivative of the numerator is 9e to the 3x over derivative of the denominator is 10. And then we sub in and we get 9 over 10. So our answer here is 9 over 10. Multiple choice, obviously you don't have to show this much work. You just kind of like blow through it. Keep checking every time you use L'Hopital's rule. You have to get 0 over 0 or infinity over infinity. Once you get something else, you have an answer. The answer might be 0. The answer might be does not exist or infinity. But as soon as you get something other than 0 over 0 or infinity over infinity, you're done. Don't use L'Hopital's again. All right, so 9/10. New problem. All right, derivative with respect to x of the integral from negative 4th root of 3 to x to the 4th of arctan of t squared dt. All right, derivative of an integral, that second fundamental theorem, which might be my favorite thing to do because it's like, it's kind of the easier version, right? Because you don't have to find an antiderivative. First fundamental theorem, the annoying part is actually figuring out like what's the antiderivative of that integrand. This one, we don't need to do that. We just need to remember the chain rule. So derivative, this thing evaluated at the upper bound. So we're going to get arctan of, so it's the quantity x to the 4th squared, which is just x to the 8th, times the derivative of the upper bound. So times 4x cubed. I feel like on a multiple choice they would rearrange that and put the 4x cubed in the front, but doesn't matter. We definitely got that one done. All right, and let's take a look at number 10, which is the last one in this problem set. But remember, there's a bunch of other problem sets. They're all in the playlist. I definitely recommend that you watch them. So number 10, the table above gives selected values for a twice differentiable function f. Which of the following must be true? Okay, so this is actually multiple choice. So key thing here, we're looking for something that is true. So what do we know? I mean, just like look at all the values, right? So function is definitely twice differentiable, which means the function is continuous, and the derivative is differentiable, which means the derivative is continuous. All of that's good to know. I feel like if you look at these, so option A, f has no critical points in the interval from -2 to 4. The only things that we know about this function are these 4 points in the table. We do know that, like, generally speaking, the function increases on this interval, but we don't know, like, maybe f of 0 is 1,000,000. Maybe f of 0 is -1 million. We just don't know. So look through the answer choices, and if you look, you see that f has no critical points. F prime is greater than 0. That's an assumption they want you to make. But it doesn't need to be true because we just know what's in the table. F double prime is less than 0 for all values. That one's actually particularly tricky because if you look if you look at just the y values and ignore the x values, right? You would think that the changes in x are, increase by 12, increase by 11, increase by 7. And you'd be like, yeah, I guess that's kind of like concave down, but they're not on even intervals, and also, like, I'm not even going to bother to calculate them. because all of these things are just way too general. I don't think any of them could be the answer. So I'm going to cross this out. I'm also going to cross this out, and I'm going to cross this out. I'm crossing them out because they're just like really broad generalizations, which may be true. Like if B doesn't work out, then I'll go back and reconsider them. But I'm pretty sure B, because it's so specific, is probably going to be the actual answer. So let's see. So I would circle it. Let's see if it's actually justified. So I'm going to do some like average rates of change, I guess. So here I go 12 up and only 1 over. Here I go 11 up, but I actually go 4 over. So I don't know why I put 2 there. So this is, I went from an average rate of change of 12 to an average rate of change of really 11 over 4, so like 2.25, but seems to be a theme in these videos. I have to make a mistake somewhere. It's one of the problems with writing your own problems, then solving your own problems and having no one else look at them. All right, so either way, because my mistake was fortuitous, 5.5 is actually less than 6. I am okay here with kind of generalizing. So you should be using 2.25 because it should be 11 over 4. But we know the function's twice differentiable. So we could use the mean value theorem on f to show that f prime must be equal to 12 for some value between -2 and -1. And f prime must be equal to really 2.25. For some value between -1 and 3. So we would be showing that the derivative is less than 6 and then greater than 6. Now twice differentiable means that the derivative is continuous. On a continuous function, we can use the intermediate value theorem. So from there, I would use the intermediate value theorem. This is all like if this was a open-ended question. I'm pretty convinced at this point that this is the answer. But I would use the IVT to show that f prime must be 6 because we're below 6, then above 6. So IVT guarantees that we're equal to 6 for some x between C1 and C2. So that's if it's open-ended. But the way that we've done it, we've eliminated A, C, and D and just chose B right away. But you can actually like get B as an answer as well. All right, so that was a bunch of questions, some tangent lines, some second fundamental theorem, this here table problem that we have to do some stuff with. I hope you found all of this helpful, and good luck.